New data from the James Webb Telescope confirms that asteroid 2024 YR4 poses a risk to Earth or the Moon. Astronomers recently discovered the celestial body and have refined its trajectory. It has been revealed that there is a chance of a direct impact on Earth and a 4% probability that 2024 YR4 could collide with the Moon in the not-too-distant future. Such a scenario would have spectacular consequences. A bright flash visible worldwide in the sky and a wealth of valuable data for asteroid research. The countdown to collision is on. Where will asteroid 2024 YR4 strike? On Earth or on the Moon? On December 27, 2024, researchers from the Atlas project in Chile discovered asteroid 2024 YR4 for the first time as a barely perceptible point of light moving slowly against the starry background. Just 2 days earlier, it had passed Earth almost unnoticed, hidden in the sunlight. The discovery was a coincidence and triggered a chain of events that caused worldwide unrest. On January 3, 2025, NASA classified the asteroid as a 4 on the Turn scale, an alarmingly high rating that means that there is a real danger of a global catastrophe. Only a few asteroids have ever reached this level. The potential impact time was calculated as December 22, 2032. The trajectory was unusually inclined, the speed was high, and the uncertainties in the calculation left room for speculation and grim scenarios. On March 14, 2025, the all-clear was given. New data from the James Webb Space Telescope and the Subaru Telescope in Hawaii enabled more precise orbit tracking. The probability of impact fell from an initial 2% to less than 0.00002%. The danger to Earth was thus averted, at least for the time being. What would have happened in the worst case? With a diameter of about 60 m, 2024 YR4 would have released an energy of around 10 megatons upon impact, equivalent to the explosive power of a large hydrogen bomb. An impact in a populated area would have had devastating consequences. Shock waves, firestorms, massive destruction, and weather disturbances caused by dust and debris. An impact in the ocean could have triggered deadly tsunamis. Global infrastructure would have been endangered by shock waves and electromagnetic effects. While the risk of impact to Earth has since been corrected, the Moon has come under the scrutiny of researchers. Initial indications suggest that 2024 YR4 could hit our satellite rather than Earth when it returns in 2032. Impact on the Moon, 4% chance of total destruction. No one initially expected an impact on the Moon, and it's surprising that a lunar impact would be almost as devastating as an impact on Earth. In June 2025, researchers from the University of Western Ontario and Arbaska University published a disturbing study. Asteroid 2024 YR4 could hit the Moon on December 22, 2032 with a probability of 4.3%. That is the highest impact probability currently known for our satellite and more than twice as high as the risk of an Earth impact. The calculations are based on high-resolution observations made by the James Webb Space Telescope in May 2025 with a diameter of approximately 53 to 67 m. Y4 is comparable to the Chelyabinsk meteorite that exploded over Russia in 2013. If YR4 were to hit the Moon, it would release an energy equivalent to around 6.5 megatons of TNT, enough to create a crater approximately 1 kilometer wide. So far, so good. The crater and the shock wave to the Moon should not pose a real problem for us. But simulations by researchers have shown that an impact could also send up to 100 million kilograms of lunar material into space. Particularly explosive, around 10% of this rock mass could overcome the Moon's gravity and reach the vicinity of Earth within a few days. Although most of the debris would burn up upon entering the atmosphere, there would still be a risk to satellites. A rain of millimeter to centimeter-sized particles could damage satellites in low Earth orbit. Communication systems could fail, televisions would go silent, and large constellations such as SpaceX Starlink satellite network would be rendered useless in the worst case. The damage would be immense. The study also warns of a possible increase in small meteorite impacts. After the Moon impact, 1,000 times more small rocks could rain from the Earth's sky than normal. The authors of the study recommend that space agencies should also examine whether a planetary defense mission to deflect YR4 is justified in the event of a possible Moon impact. So far, Such plans only exist to defend Earth. But we also depend on the safety and stability of the Moon, and we must protect our satellite as we protect ourselves. Since the asteroid cannot be observed again until 2028, the uncertainty remains until then. The big Moon collision, a horror scenario for us, too. Let's imagine the worst. On December 22, 2032, asteroid 2024 YR4 hits the Moon with full force. Traveling at over 13 km per second, it strikes the dusty surface, unleashing more than 6.5 megatons of TNT in a fraction of a second. The explosion would be visible from Earth. A bright flash of light followed by a gigantic cloud of dust that would cover the lunar landscape like a grey veil. A new crater over a kilometer wide gapes in the surface. A scenario that sounds terrifying yet fascinating. It would be a spectacular sight to behold from Earth. But the real danger only begins after the impact. Billions of tons of moon dust and rock would be hurled into space. Moon dust is dangerous. It is as fine as powder and as sharp as glass. The Moon astronauts learned this the hard way in the 1960s. Their moon suits were defective, and back on Earth, the moon dust they brought back with them caused illnesses among the astronauts and NASA employees. When this razor-sharp powder leaves the Moon's gravity and begins its journey to Earth, a scenario unfolds that is difficult for us to imagine. Within a few days, thousands of particles could enter the atmosphere. Most of them burn up, but some reach the surface. Micrometeorites could puncture satellite solar cells, paralyze communication systems, and disrupt navigation networks. Scientists warned that a sufficiently large amount of the pulverized moon rock could enter the upper atmosphere. In the worst case, this dust would reflect sunlight and plunge the Earth into a temporary twilight state. A mini-nuclear winter would be conceivable, resulting in a global temperature drop of several degrees. Disrupted weather patterns and crop failures. Space telescopes worth billions of dollars could suffer severe damage. Although the Interstellar Space Station has protective shields against such impacts, even these protective systems would be unable to withstand a sudden increase in the flow of meteoroids by a factor of 1,000. On the Moon itself, rover missions are at risk. And if we experience a devastating impact, future lunar stations such as NASA's Artemis program or China's Changi base will have to be completely re-evaluated. As we build more infrastructure in space, the risk of damage from meteorites, moon dust, asteroids, and comets also increases. Imagine we have the first settlements on the Moon. The lives of the people there would be even more vulnerable to disruption. If supply systems fail, breathing air and water supplies could quickly run out. Moonquakes could destroy habitats, and toxic dust could penetrate and destroy settlements. The potential impact on the Moon is currently seen as a warning to make planned settlements, lunar vehicles, and spacecraft even safer. In light of the current threat, NASA is discussing space stations with improved shielding materials, early warning systems for micrometeorite streams, and a kind of cosmic weather radar. Scientists are discussing the idea of moving critical systems to higher orbits. But danger lurks everywhere. The fact is we are vulnerable, and asteroids are ticking time bombs that threaten not only our terrestrial systems but also our advancing civilization in space. Will asteroid 2024 YR4 be towed away? What would be the optimal defense for an asteroid that threatens the Moon but not Earth? With the discovery of 2024 YR4, which currently poses no immediate threat to Earth, but could hit our satellite, the debate about global asteroid defense is taking on a whole new dimension. Initial practical tests have already shown that defense missions are no longer just science fiction. In 2022, NASA's DART mission provided the first direct evidence that an asteroid can change its trajectory far enough through a targeted impact so that it can be pushed out of the danger zone if detected in time. The double asteroid redirection test crashed into the small asteroid moon Dimorphos at around 23,000 km per hour and shortened its orbital period by more than half an hour, far more than originally expected. Europe will soon be working with the ESA mission HERO to remeasure this cosmic push. The probe is scheduled to reach Dimorphos in 2026 and enable even greater accuracy through measurements and analyses. The fact that DART pushed the probe too far could also be a problem in an emergency, especially when time is short. Other concepts envisage the use of gravitational tractors. These would be heavy space probes that would use their gravitational pull alone to minimally alter the course of an asteroid over a period of years. Additional laser beams or special solar sails would vaporize material from the surface, thereby generating extra recoil forces. In the case of 2024 YR4, there is discussion as to whether the asteroid could be a good object for testing a towing project. In this scenario, a fleet of robotic space probes could approach the dark chunk in space. A guide probe would hover close to its surface, drill harpoons into the rock, and then stretch nets or cables around the asteroid. Attached to these lashing straps, the probe would then act as a giant cosmic transporter, firing ion thrusters to tow the object slowly but steadily. The operation would take weeks or months to pull the body millimeter by millimeter out of its original orbit. 2024 YR4 and the possible moon impact could be a perfect practice target. However, towing systems for asteroids are still in the planning stage. The asteroid will be close to Earth again in 2028, at which point probes could begin to deliberately move the chunk of rock. Cameras would constantly monitor the process, allowing scientists to plan every step of the operation. Small companion probes would be used to ensure the cables remained taut. These probes, in the form of many robots, could also carry out minor repairs and corrections. This scenario is conceivable and is no longer pure fiction. In 2018, the Japanese Space Agency landed a multi-art probe on the asteroid Ryugu. Hayabusa 2 consisted of the lander, an impactor that took samples, and a camera. In a follow-up mission, a small rover was placed on the asteroid to observe the object permanently.